Claude Code is not a chatbot. It's the AI that does the work for you. You're still copy-pasting outputs into your project. You're still the one doing the actual work. That stops today. This thing reads your files, writes the code, and ships it. In this video, we go from zero to full deployment. No coding experience. Every command included. I'm Chris, founder of Execution Squad. I built an AI consulting business to $600,000 in 1 year. Then I shut it down because I watched what it was doing to people. Let's start. Beginner track, sections 1 through 5. If you're new to Claude Code, start here and stop at the split moment. Before we start, two things. You need a Claude Pro plan. Free plan doesn't include Claude Code. Check current pricing at Claude.ai. Second, go to code.claude.com/docs. That's your documentation home. Everything we cover lives there. Done. Let's install. You're looking at the official Claude Code documentation. Find the install command here. Scroll down until you see a curl command. It starts with curl. Copy it. Open your terminal. Mac, command plus space, search terminal. Windows, open CMD. Paste the command and hit enter. Watch it run. Done. Type Claude and hit enter. You're in. Look at the welcome screen. Bottom of the box shows your model, your plan, and your working directory. That's your session info. Opus 4.6, your plan, and the folder you're working in. All right there. If you don't have an Anthropic account yet, go to anthropic.com and sign up. Then type /login in Claude Code and follow the prompt. Browser opens, login, come back. When it's done, you're in, installed and authenticated. Quick note, you can also run Claude Code inside a visual editor. Two options worth knowing. First, Visual Studio Code. Install the Claude Code extension from the extensions panel. Look for the Anthropic verified version with the checkmark. Second, Antegravy. Google's AI coding platform, built agent first from the ground up. Same Claude Code capabilities in both, just a visual interface instead of a plain terminal. And terminal is better for advanced use. Start with whatever feels natural. Everything in this tutorial works in both. I'll be using Antegravy for the demos in this video. Download Antegravy at antegravy.google and sign in with your personal Gmail account. Once you're in, open the extensions panel on the left sidebar, search Claude Code, find the Anthropic verified version with the checkmark and install it. That's it. Claude Code is now running inside Antegravy. Once it's installed, look at the top right corner. You'll see the Claude Code icon. Click it. That opens the chat panel where you start your conversation. That's where everything happens. Section 2, Claude.MD, your project brain. This is the most important concept in the video. Pay attention. Claude.MD is a file that gets injected into every conversation before your first message. You never see it in chat. Claude reads it before you say a single word. Think of a ship leaving a harbor. A 1-degree error at departure means missing your destination by thousands of kilometers. Claude.MD sets that angle before anything else runs. Here's why it matters practically. Without it, Claude starts from zero every session. With it, Claude already knows your project, your rules, your preferences. It also cuts your token spend because Claude doesn't reread all your project files every time. Claude.MD loads every session and it's always billable, so keep it tight. Let me put it another way. Imagine hiring a contractor every single morning. Every morning they show up and they don't remember anything from yesterday. They don't know your project. They don't know your standards. They don't know what you've already tried that didn't work. So you spend the first 30 minutes of every session just catching them up. That's what working without Claude.MD feels like. You're re-explaining context every single time. Claude.MD is the briefing document that's already on their desk when they walk in. They read it, they know the rules, and they start working immediately. One naming rule, the file must be called Claude.MD, capital letters. Case matters, place it in your project root or inside .claude/claude.md. There are 3 layers. Global at ~.claude/claude.md applies to every workspace you open. Local at .claude/claude.md applies to the current project only. Enterprise is system level. Ignore it, you won't need it. Global beats local. In practice, you control the global rules and team members manage their own local ones. Think about when this matters. Your global Claude.MD might say, always use TypeScript, never use JavaScript, and always respond in Spanish. That applies everywhere. Your local one might say, this project uses Supabase for the database, and the API roots live in /src/API/. Global handles your identity. Local handles the project. They work together. If they ever conflict, global wins. That hierarchy is important to understand because if you put a project-specific rule in your global file, it leaks into every other project. Keep them clean. Every serious Claude Code project has a .claude folder. The dot at the front hides it from file explorers. That's standard convention. Inside it lives everything. For now, our setup is simple, just the Claude.MD file. As your project grows, you can add more files inside this folder for agents, skills, rules, and MCP configuration. The .local rule is worth knowing even now. Any file with .local in the name is git ignored. It never leaves your machine. API keys, tokens, personal overrides all go here. And instead of one huge Claude.md, you can split it into focused files inside a rules folder: code-style.md, testing.md, security.md, frontend.md. To do it, just tell Claude, split Claude.md into its component rules using the Claude Code rules specification. It handles the rest. Here's why splitting matters. When your Claude.md hits 300, 400, 500 lines, it becomes hard to maintain. You change one thing in the testing section and accidentally break a rule in the security section. Splitting it into focused files means each file has one job. Your code style rules live in one place. Your testing rules live in another. You can update one without touching the others. And when you onboard a new team member, they can read just the file that's relevant to them instead of a 500-line wall of text. But don't split too early. Start with a single Claude.md. When it gets messy and hard to maintain, that's when you split. Premature splitting creates the opposite problem: too many small files that are hard to find and easy to forget about. Here's what a bad Claude.md looks like. 2,000 words. Reads like a document, not a rule set. Most important instructions buried in the middle. Claude will mostly ignore it. I've seen people paste entire API documentation into their Claude.md, hundreds of lines of endpoint descriptions, parameter lists, response formats. Claude doesn't need that. Claude can read the actual API docs from your project files at runtime. What it needs in Claude.md is the rule. Always use the v3 endpoint, never the v2, not the documentation of what the endpoint does. There's a massive difference between telling Claude how to behave and giving Claude reference material. Claude.md is for behavior. Reference material lives in your project files. Another common mistake. People write their Claude.md like they're writing an essay. Full paragraphs, transitional sentences, context setting, introductions. Claude doesn't need a story. It needs instructions. Use Tailwind for all styling. No inline CSS, no CSS modules. That's 3 rules in 3 lines. Compare that to when working on the front end of this project. Please make sure to use Tailwind CSS for styling purposes. We prefer not to use inline styles or CSS modules as they don't align with our team's conventions. Same information, 4 times the tokens, 0 additional value. Good Claude.md is the opposite. First line is your most important rule. Always, if there's one thing Claude must never do, it goes at line 1. Below that, bullet points, short, dense, each one actionable. 200 lines maximum. Longer than that and it's carrying dead weight. This is primacy bias. Claude remembers the top best, the middle least, the end second best. Write your Claude.md accordingly. This changes how you structure everything. Your most critical rules go at the very top. Line 1, line 2, line 3. Things that would break your project if violated. Then your general coding standards in the middle. Then your less critical preferences at the bottom, because the bottom is the second strongest recall position. The middle is the dead zone. If you have a rule in line 150 of a 300 line file, Claude might miss it. Move it up or move it down. Never leave important things in the middle. And here's a practical tip. When Claude makes the same mistake twice, that's your signal. Don't just fix it in the chat. Go add a rule to your Claude.md. Never use relative imports in the /API folder. Always add error handling to database queries. Test files go in tests, not next to the source file. Every repeated mistake becomes a permanent rule. Over time, your Claude.md becomes a perfect reflection of how you want your project built. It's not something you write once, it's something that grows with you. Run /init first in any new project folder. Use bullet points and short headings, high information density. Put critical rules at the very top. Treat it like technical debt. Review and prune it regularly. Add a rule every time Claude makes the same mistake 2 or 3 times. Keep it to 200 to 500 lines maximum. Don't dump entire style guides or API docs. It wastes tokens and degrades quality. Don't write vague rules like be smart or make no mistakes. Claude ignores them. That last point deserves emphasis. Vague rules are invisible to Claude. Be careful with the database means nothing. Always use transactions for multi-table writes. Never delete rows. Use soft deletes with a deleted underscore at timestamp. That means something. Every rule should be specific enough that you could check whether Claude followed it or not. If you can't verify it, it's not a rule, it's a wish. One more thing. Claude also has a Memory.md file. Say, remember that X, and it saves across sessions. Useful for personal preferences that don't belong in your rules. You don't need to manage it. Claude handles it automatically. The difference between Memory and Claude.MD is simple. Claude.MD is project rules, shared, deliberate, maintained by you. Memory is personal context, things like I prefer dark mode examples, or I'm working on the billing feature this week. Memory is convenient, but it's not reliable for critical rules. If something matters to your project's quality, put it in Claude.MD. If it's a personal preference, that would be nice, but not critical. Let Memory handle it. Section 3. Build a website, the screenshot loop. This is the method you'll use most. It's the one that actually works. Go to Golly.website, browse the designs, pick one you want to replicate. Right-click on the page and select Inspect, or press Command plus Shift plus I on Mac, Control plus Shift plus I on Windows. DevTools opens. Click the device toolbar icon and set width to 1920, height to 1080. That captures the full desktop layout. Now open the command palette with Command plus Shift plus P on Mac, or Control plus Shift plus P on Windows. Type screenshot and select Capture full-size screenshot. Browser downloads the image. Head to resizepng.com. Upload it, bring it under 5 megabytes, download it, open Claude Code, paste the screenshot directly into the chat. Then go back to DevTools, find the body tag in the Elements panel, right-click it, select Copy Styles, and paste that into the same message. Now type your instruction, recreate this website design exactly, match the layout, fonts, colors, and spacing, output clean HTML and CSS. Hit enter, first pass, open it in the browser, maybe 80% there. Colors close, layout right, some spacing off. Take a screenshot of the current version, paste it back into Claude Code alongside the original, and tell it, here is the current version next to the original. Close the gap, focus on the spacing, font weight, and card alignment. Second pass, significantly closer. That's the loop. Task, do, verify. Every iteration tightens it. Keep going until you're satisfied. There's no limit on how many rounds you run. Each pass gets closer. The rule underneath all of this, without a verification step, screenshot comparison, automated tests, anything, you lose most of the value. AI isn't valuable because it's precise. It's valuable because it iterates fast. Build the loop. Don't skip it. 2 other approaches worth knowing. Hold the FN key and voice dump your requirements. You speak much faster than you type, and Claude extracts what matters. Or browse 21st.dev for pre-built component prompts, best for specific UI elements like buttons and cards. If you're building seriously, listen up. Every Friday, I run a free live training where I break down the 5 numbers that explain why you have 0 clients and the system that fixes it. One student made $30,000 in 70 days. Another got his first client in 7 days. Show up live, you get the diagnostic template my paid clients use, no replay. iChrisley.com/training, link in the description. That covers website building. Now let's talk about how you control what Claude is allowed to do. Section 4, permissions and plan mode. 4 permission modes. Toggle between them with Shift plus Tab. Ask before edits is the default. Asks before any file change. Use when learning or doing high stakes edits. Edit automatically auto-accepts edits, but still asks before new file creation. Use for most intermediate work. Plan mode is read only, no changes. Use for complex task planning. Bypass permissions has no restrictions whatsoever. Power users only, with caution. Right now, you're in Ask Before Edits mode. That's the default. Claude asks permission before changing anything. Hit Shift plus Tab, you move to Edit automatically. Shift plus Tab again, Plan mode. Read only. Claude can think and research, but won't touch any files. Let me explain why these modes exist and when you'd actually switch between them. Ask Before Edits is training wheels. It's there so you can see exactly what Claude is about to do before it does it. Every file change, every new file, Claude stops and asks. When you're new, this is valuable. You learn what Claude is doing, you understand the changes, you build trust. But once you've been using Claude Code for a week or 2, this mode becomes a bottleneck. You're clicking yes 50 times in a row because you already know what Claude is doing. That's when you switch. Edit automatically is where most people should live day to day. Claude makes file changes without asking. It just does it. But it still asks before creating brand new files. That's an important safety net. Claude can edit your existing code freely, but it can't suddenly create 15 new files you didn't expect without checking with you first. This is the sweet spot between speed and control. You're fast, but you're not reckless. There's also a fourth mode called bypass permissions. No restrictions, no asking. Claude acts immediately on every instruction. It requires enabling separately in settings. Use it only when you're confident in the task. And periodically ask Claude to clean up the workspace. Temp files and unused libraries accumulate fast. A word of caution on bypass. I've seen people turn it on and forget about it. Claude starts creating files, installing packages, modifying configs, all without asking. If you're running a well-defined task with a clear scope, that's fine. But if you give a vague prompt in bypass mode, Claude will make decisions for you that you might not agree with, and you won't know until you look at the damage. My rule: use bypass for tasks you've done before and fully understand, never for something new or experimental. And when you're done with the task, switch back. Don't leave it on. Here's a pattern that works well in practice. Start every new project in ask before edits. Get comfortable with what Claude is doing. After the first session, switch to edit automatically for the rest of the build. If you hit a complex decision point, like choosing between two different database architectures, switch to plan mode temporarily, think it through, then switch back. Bypass only for repetitive, well-understood bulk tasks, like rename every instance of X to Y across the code base. Match the mode to the risk level of what you're doing right now, not what you were doing 10 minutes ago. Plan mode, use it more than you think. It's read only. Claude browses the web, reads your files, reasons through the problem, and outputs a plan document. 0 changes made. Think about what happens without it. You build the wrong thing, test it, rebuild it, test again. You're burning an hour without realizing it, plus the token cost of all that back and forth. Plan first. Catch the problem before a line of code is written. Blueprint changes cost nothing. Construction changes cost everything. I cannot stress this enough. Plan mode is the single biggest money saver in Claude Code. Not because planning is free, it costs tokens too, but because building the wrong thing costs 10 times more. Every time you let Claude start coding without a plan, you're gambling that it guesses your intent correctly on the first try. Sometimes it does, often it doesn't. And when it doesn't, you're not just fixing one thing, you're unwinding decisions that are now baked into your file structure, your database schema, your component hierarchy. One wrong assumption at the start cascades into 20 fixes later. Think about it from a token perspective. A plan costs you maybe a few thousand tokens. Building the wrong thing and rebuilding it costs you tens of thousands. I've watched people burn through their entire daily token budget because they skipped the planning step and spent the whole session going back and forth with Claude trying to fix an architecture that was wrong from the beginning. 5 minutes of planning would have saved them an hour of building and rebuilding. Here's when you should always use plan mode. First, anytime you're starting a new project from scratch, always plan first. Second, anytime you're adding a major feature that touches multiple files. Third, anytime you're not sure how something should work. If there's any ambiguity in your head about what you want, plan mode forces you to resolve it before code exists. Fourth, anytime you're about to integrate a third-party service, Stripe, Supabase, an external API. The integration points are where the most mistakes happen, and a plan catches them early. And here's a habit that separates beginners from people who actually ship fast. Read the plan. Don't just glance at it and say, looks good. Actually read it. Check the file structure. Check the tech stack decisions. Check the user flow. If something feels off, tell Claude to revise the plan. Revising a plan takes seconds. Revising build code takes the entire session. The plan is your last chance to catch mistakes for free. Switch to plan mode with Shift plus Tab. Type, I want to build a client onboarding system for my coaching business. It needs a form where new clients fill out their goals and background, a way to automatically send them a welcome email with next steps, and a dashboard where I can track all active clients and their progress. What's the best approach? Claude researches and reasons, not touching a single file. Then it outputs a structured plan, overview, tech stack, user flow, file structure, step-by-step build order. Read through it. Notice what it caught before a line of code was written. It already made a significant architecture decision for you. Public intake form for clients, separate password-protected dashboard for admin only. Two completely different access levels. If you'd started building without a plan, you might have built everything behind a login and locked out your own clients from submitting their form. Fix it now, not mid-build. Switch out of plan mode and build from a blueprint, not from guesswork. That example right there is worth the entire section. A public form versus a protected dashboard is a fundamental architecture split. It affects your routing, your authentication logic, your database permissions, everything. If you'd caught that mistake mid-build, you'd be ripping out half your code and starting over. In plan mode, it cost you nothing. Claude flagged it in 30 seconds. That's the whole point. One more thing about plan mode that people don't realize. The plan itself becomes a reference document. After Claude builds the project, you can always go back to the plan and check whether the build matches what was agreed. It's your blueprint. If Claude drifted from the plan during building, you can point to it and say, this isn't what we planned, fix it. Without a plan, you have nothing to compare against. You're just guessing whether the output matches your original intent. The plan makes intent explicit. That's powerful. Section 5, full stack app build. This is the most complex section in the beginner track. You don't need to understand everything happening under the hood. Follow the steps in order. Claude handles the technical details. This is the whole beginner workflow in one go. We're building a proposal generator, login, proposal creation, e-signatures, payments, templates. Let's build it. Start with a fresh folder, no files, just Claude Code open. Step 1, switch to plan mode first. Then type your requirements directly into Claude Code. Say something like, I want to build a tool where I can create business proposals for clients. Clients should be able to log in, view their proposal, sign it digitally, and pay a deposit. I want to be able to set the price and create templates for different service types. Hit enter. Step 2, Claude will ask a few clarifying questions. Framework preference, database, signature style, payment type. Answer them. No preference on framework, Superbase for the database. Proper drawn signature, one-time deposit. Claude outputs a full plan. Read through it enough to feel confident. You're just checking it described your product correctly. Step 3, switch to edit automatically. Tell Claude to start building. Step 4, while Claude builds, open Superbase in another tab. Create a new project, name it anything. Go to project settings, then API. Copy the project URL and the anon/public key. When Claude asks for them, paste them in. Step 5, open Stripe in another tab. Create a sandbox account if you don't have one. Go to developers, then API keys. Copy the publishable key and secret key from the test environment. When Claude asks, paste them in. Step 6, Claude will output a SQL migration script. Open the Superbase SQL editor. Paste the migration. Click Run. Tables created. Done. Step 7. Claude finishes building. Open your terminal, navigate to the project folder and run npm run dev. Open the localhost URL in your browser. Log in with your admin account. You're in. The app is live with auth and database fully connected. From here, you'd wire up Stripe for payments, add e-signatures, build out email notifications, all single prompts. Each one follows the same pattern. Tell Claude what you want, let it build, verify the result. Takes a few minutes each. When you're ready to go live, one prompt pushes it to GitHub and deploys to Netlify. Environment variables, build config, domain setup, Claude handles all of it. You get a live URL at the end. Auth connected, database running, payments wired up. The whole thing, maybe 15 to 20 minutes start to finish. That's the beginner track. Every step from here follows the same workflow you just learned. One tip, when Claude tells you to do something on an external service, just ask, can you do all this for me? Claude handles more than you'd expect. Beginner track ends here. Come back to the advanced track when you've used the basics for a while. What follows is context management, token economics, skills, MCPs, and sub-agents. These are the systems that separate someone who uses Claude Code from someone who runs it. We go deeper. Claude Code, Advanced Track, Sections 6 through 9. If you have used the basics, start here. Section 6, Context Management and Token Economics. Context management is handling tokens in a prompt as effectively as possible. Master this section and everything else in the advanced track costs you less to run. Most people treat Claude Code like an unlimited resource. They type, Claude responds, they type more. They don't think about what's happening under the hood. Then they hit a wall. Claude starts forgetting things they said 20 minutes ago. Responses get worse. The session feels sluggish. They think Claude is broken. It's not broken. The context window is full. Everything they've been saying, every file Claude read, every response Claude gave, it's all sitting in memory and there's a hard ceiling. When you hit it, Claude starts dropping the oldest information to make room for new information. That's when quality collapses. Context management is how you prevent that from ever happening. And there's a cost dimension too. Every token that loads into your context window is billable. Your Claude.MD, your MCP tools, your conversation history, all of it costs money every time Claude processes a message. The bigger your context, the more you pay per interaction. So context management isn't just about quality, it's about your wallet. The people who understand this section spend a fraction of what everyone else spends and get better results. Your primary diagnostic tool is /context. Run it anytime to see exactly where you stand. First, the definition. A context window is the total tokens a model can process in one session. Your window size depends on your model and plan. Run /context to see yours. And one thing worth knowing, context window size is not the same as model intelligence, separate dimensions entirely. That distinction trips people up. They think a bigger context window means a smarter model. It doesn't. Context window is memory capacity, how much information the model can hold at once. Intelligence is reasoning ability, how well the model thinks through problems. You can have a massive context window and mediocre reasoning, or a smaller context window and brilliant reasoning. They're independent. Opus has strong reasoning. That's why it's the parent agent. Sonnet and Haiku have large context windows and are cheaper. That's why they're subagents. You match the tool to the job. Not every job needs the smartest model. Most jobs need enough memory and decent reasoning. Here's what loads before your first message even sends. System prompt, your CLAUDE.MD and rules. Variable cost, you control this. System tools, about 17,000 tokens every session, cannot remove. MCP tools, variable, you control this. Memory.md, small, typically under 100 tokens, auto-managed. Skills front matter only, about 60 to 65 tokens per skill, you control this. Messages grow with conversation, unavoidable. Free space is the majority of window in a fresh basic setup. Open a fresh Claude Code session. Don't type anything yet. Type /context and ask it to display the breakdown. Hit enter. Look at this. You haven't typed a single real message and you've already used a chunk of your context window. That big number is system tools. Around 17,000 tokens. Built-in Claude Code capabilities. Bash, web search, file reading, file writing. Every session can't remove them. Next, your Claude.MD. Whatever's in it, it's loaded right now. And MCP tools, if you have any installed, they're loading here. This is where costs spike fast. Everything in this breakdown is billable every session before you say a word. Here's a mental model that helps. Think of your context window as a room. The system tools are the furniture that came with the room. You can't move it out. Your Claude.MD is a bookshelf you brought in. You control how big it is. Your MCP tools are extra equipment. Each one takes floor space. And your conversation is people walking into the room. The more people, the more crowded it gets. At some point, people start getting pushed out the door. That's auto compaction. Your job is to keep the room as open as possible so the conversation has space to breathe. 7 strategies to keep your token spend low. These are the ones that actually move the needle. Strategy 1. Check your spend anytime. Type /cost and you get your running total for the session. Make this a habit. Check /cost every 15 to 20 minutes during a session. Not because you need to panic about spending, but because it gives you awareness. You start to develop an intuition for what's expensive and what's cheap. You'll notice that a single vague prompt that triggers Claude to read 10 files costs more than 5 specific prompts combined. That awareness changes how you work. You stop being wasteful without even thinking about it. Strategy 2. Type /clear when switching tasks. Context nearly zeroed. Use this every time you move to a completely different task. This is the most underused command in Claude Code. People finish building a feature, then start working on a completely different feature in the same session. All that history from the first feature is still sitting in context. Claude is carrying the memory of every file it read, every change it made, every conversation you had, none of which is relevant to the new task. That dead weight makes Claude slower and dumber on the new task. /clear wipes it clean. Fresh start, it takes 1 second and it immediately improves the quality of everything that follows. Clean slate, clear focus. One thing to watch out for though, /clear is aggressive. It wipes almost everything. If there's something from the previous task that's relevant to the next task, either put it in your Claude.MD first or use /compact instead. /clear is for clean breaks. /compact is for selective memory. Strategy 3, custom compaction. Type/compact followed by what you want to keep. Something like focus on the AI agent workflow and the API integration. Discard the debugging conversation. Claude compresses the history and prioritizes what you told it to keep. Auto compaction triggers automatically when your context gets full, but manual compaction lets you control what survives. The difference between auto compaction and manual compaction is control. When Claude auto compacts, it decides what to keep and what to drop. Usually it does a decent job, but sometimes it drops something important because it didn't know that detail mattered to you. Manual compaction puts you in charge. You tell Claude exactly what's important. Keep the database schema decisions and the API endpoint structure. Everything else can go. Now, Claude compresses intelligently, preserving the things you care about and discarding the noise. Here's when to manually compact. You're mid-session, maybe 30 to 40 minutes in. You've had a productive conversation, built some things, debugged some issues, but you can feel the context getting heavy. Responses are slightly slower. Claude is occasionally forgetting something you said earlier. That's your signal. Don't wait for auto compaction to kick in. Manually compact now while you still control what survives. If you wait until the context is completely full, auto compaction makes the choice for you, and it might not choose what you'd choose. Strategy 4, add a conciseness instruction near the top of your Claude.MD. Write as succinctly as possible. Give me bare bones information unless I ask for more. Every response tightens, fewer tokens per exchange. This one is subtle, but it compounds massively. Every Claude response is tokens. A verbose response might be 500 tokens. A concise response might be 100 tokens. Over a 50 message session, that's the difference between 25,000 tokens of responses and 5,000 tokens of responses. Same information, 5 times the cost difference. And here's the thing, verbose responses aren't just expensive, they're worse. They fill your context with fluff. Claude starts processing its own verbose explanations as part of the conversation history, which makes future responses even more bloated. Conciseness isn't just a style preference, it's a performance optimization. Strategy 5, right model for the task. Use Sonnet or Haiku for sub-agents, cheaper, larger context windows. Reserve Opus for the parent agent doing synthesis. Most tasks don't need Opus. That's hard for people to hear because they want the best model for everything. But think about what a sub-agent actually does. It runs a web search and summarizes the results. It reviews code for obvious issues. It generates test files. These are well-defined, focused tasks. Sonnet handles them perfectly. Haiku handles most of them too. The parent agent, the one that's making architecture decisions, coordinating between sub-agents, synthesizing multiple sources of information, that's where Opus earns its cost. Using Opus for a simple code review is like hiring a CEO to do data entry. It works, but you're wasting money. Strategy 6, audit your MCPs. If your MCP tools are eating a significant portion of context, Claude can search tools dynamically instead of loading all of them upfront. Run /context to see exactly what's loading. This catches people off guard. They install 3 or 4 MCPs because they sounded cool, then wonder why their context is half full before they start working. Each MCP loads its tool definitions into context. Some MCPs register dozens of tools. Each tool has a name, description, parameter list. It adds up fast. I've seen setups where MCPs alone consume 30 to 40% of the total context window. That's almost half your working memory gone before you type a single word. Run /context, look at the MCP line and ask yourself, am I actually using all of these right now? If the answer is no, disconnect the ones you don't need for this session. You can always reconnect them later. Strategy 7, write specific prompts. Fix this one feature in this file beats improve this code base every time. Specific prompts cut token waste dramatically and front load your research in plan mode before building. Web requests and API calls made mid-session load large amounts of tokens. Do the research phase first, then build. When you say improve this code base, Claude has to read every file to understand what you might mean. It scans your entire project, loads dozens of files into context, reasons about what improve could mean, then makes changes that may or may not match your intent. That one vague prompt just consumed thousands of tokens in file reads alone. Compare that to fix the error handling in /src/api/payments.ts, add try-catch around the Stripe API calls. Claude reads one file, makes one targeted change. Done. a fraction of the tokens, and the result is exactly what you wanted. The research point is equally important. When Claude browses the web or calls an API mid-session, the responses get loaded into context. A single web page can be thousands of tokens. 3 or 4 web searches during a build session, and your context is suddenly packed with research data that's no longer relevant. The fix is simple. Do all your research in plan mode first. Read the docs, check the APIs, figure out the approach. Then /clear and start building with a clean context. The plan lives in your head or in a file, not eating your context window. All 7 strategies boil down to one principle: respect the context window. It's not infinite, it's not free. The less junk you put in it, the better Claude performs and the less you pay. Every optimization here compounds over time. A 10% improvement in context efficiency across hundreds of sessions saves you real money and real time. Section 7, skills. Now we get to the real leverage. Everything up to this point has been about using Claude Code session by session. You type a prompt, Claude does the work, session ends. Next time you start over. Skills change that completely. Skills turn one-time work into permanent capability. You build it once, and from that point forward, Claude can do that task instantly every time you ask. It's the difference between cooking a meal from scratch every night and having a recipe that someone else follows perfectly while you do something else. A skill is a reusable checklist you give Claude for something you do repeatedly: scraping leads, qualifying prospects, updating CRMs, generating reports. In this demo, lead scraping that previously took 30 minutes manually completed in 87 seconds with a skill. Without a skill, here's what happens. You tell Claude to scrape leads. Claude asks clarifying questions. What kind of leads? What data do you need? Where should the results go? You answer. Claude writes a script from scratch, runs it, hits an error, debugs it, runs it again, maybe hits another error, fixes that, finally gets results. 30 minutes gone. With a skill, all of those decisions are already made. The checklist exists, the scripts exist. Claude reads the skill, matches your request to it, and executes immediately. No questions, no writing from scratch, no debugging cycle. The skill already solved every problem the first time around. And here's what makes skills fundamentally different from just saving a prompt or a template. A skill isn't a static script. It's a combination of instructions and executable code held together by Claude's intelligence. When something unexpected happens, an API changes, a website restructures, a rate limit kicks in, Claude doesn't crash and stop. It reads the checklist, understands the goal, and finds a way around the problem in real time. A static script breaks. A skill adapts. Here's the file structure. Inside .claude/skills/ you create a folder for each skill. Inside that folder is skill.md and a scripts subfolder with the actual code files. 2 parts. Skill.md is the conductor. It contains the goal, inputs, process checklist, and reference information. It tells Claude what to do and in what order. Claude uses its own intelligence to handle failures and branch around errors in real time. The scripts folder is the musicians. Actual executable Python code. Deterministic, repeatable, called by skill.md, exactly like tools. You don't need to write or understand the Python. Claude generates it. This is the part that trips people up. They think they need to be a developer to build skills. You don't. You describe what you want in plain language. Claude writes the code. Claude writes the checklist. Claude connects them together. Your job is to describe the task clearly and test the result. If the result isn't right, you tell Claude what's wrong, and it fixes both the code and the checklist. You're the director. Claude is the entire production team. This is genuinely one of the most underappreciated features. Let's say your lead scraping skill runs and hits a rate limit on Google search. Claude detects the error, adds a delay between requests, and completes the task. But it doesn't stop there. It goes back to skill.md and adds a new note. Rate limit detected. Wait 2 seconds between search requests. Next time you run the skill, that problem never happens again. The skill learned from its own failure over weeks and months of use. Your skills accumulate these fixes. They become incredibly robust without you ever touching them. Every run makes them smarter. Think about what that means at scale. If you have 20 skills running regularly, each one is silently improving itself every time it encounters a problem. After a month, those skills are dramatically more reliable than they were on day one. That's compounding reliability, and it costs you nothing. You didn't write the fix. You didn't even know about the problem. Claude handled it end to end, and they're extremely token efficient. Only the top section of skill.md loads by default: name, description, allowed tools. The full skill loads only when Claude decides it's needed or you explicitly invoke it. dozens of skills combined cost almost nothing. A single MCP tool often costs more than your entire skill library. An MCP tool loads its entire definition into your context window every session. Tool name, description, parameters, response format, all of it. A single MCP with 20 tools might cost you 10 to 20,000 tokens every session, whether you use those tools or not. A skill, the front matter loads. Name, description, maybe a list of allowed tools. That's it. Under 100 tokens. The full checklist and scripts only load when you actually invoke the skill. So you can have 50 skills installed and they barely register in your context. That's a fundamentally different cost model. MCPs pay rent whether they work or not. Skills only cost you when they're actually doing something. This is why the skill-first mindset matters. Every recurring task in your workflow should eventually become a skill. Not because skills are fun to build, but because every skill you create permanently reduces the time and cost of that task. The first time takes 30 minutes to build the skill. Every time after that takes seconds. If you do that task twice a week, you've paid back the build cost in the first week. Everything after that is pure profit in time and in tokens. Part 1. Build the skill. Type out what you want the skill to do. Something like, I want a skill that automates client outreach. I give it an industry and a target region. It finds potential clients matching that description, grabs their name, website, phone number, and email where possible, scores them as high, medium, or low priority based on relevance, and exports the results to a Google Sheet. Paste that transcript into Claude Code and type, build this as a skill in .claude/skills/scrape-leads/. One tip on describing skills: be specific about inputs and outputs. I give it an industry and a target region. That's clear. Claude knows exactly what parameters to expect. It exports the results to a Google Sheet. That's a clear output. The more specific you are about what goes in and what comes out, the better the skill will be. Vague descriptions like it finds leads and does stuff with them produce vague skills. Precise descriptions produce precise skills. Claude generates skill.md and the Python scripts. Watch the file explorer. Open skill.md and look at the structure. The front matter at the top is all that loads by default. Name, description, allowed tools. The full checklist loads only when you invoke it. That's why dozens of skills can exist with almost no token cost. Skill is built. Now let's run it. Part 2. Invoke the skill. Type, scrape me 1000 cleaning services across Canada. Claude matches the request to the skill. Watch the execution. It starts with a small test scrape to verify quality before scaling up. Once it passes, it runs the full scrape, classifies every lead by priority, and uploads the results to a Google Sheet. Notice what just happened. You didn't say use the scrape leads skill. You just described what you wanted. Claude matched your request to the right skill automatically based on the description in the front matter. That's why the name and description in skill.md matter. If your description is clear and specific, Claude finds the right skill every time. If it's vague, Claude might miss the match and try to do the task from scratch. Good descriptions are like good file names. They make everything findable. Done. 1000 cleaning service leads. Name, website, phone, email, classified, under 2 minutes. Now imagine this. You have 10 skills like this. One scrapes leads, one qualifies them, one drafts outreach emails, one schedules follow-ups, one generates weekly reports. Each one takes seconds to run. Each one improves itself over time. Each one costs almost nothing in tokens. That's not a tool, that's a system, and it runs while you do other things. That's the leverage I was talking about at the start of this section. Skills turn Claude Code from an assistant into an operation. Section 8, Model Context Protocol, MCP. MCPs are skills, except someone else builds and maintains them. Developer teams, package integrations, Gmail, ClickUp, Slack, Chrome browser control, and you install them into Claude Code with a JSON snippet. Claude gets access to that software the same way it has Bash and web search natively. Where to find MCPs? mcpservers.org, github.com/model-context-protocol/servers, and mcp.market. Security note: these are third-party libraries. Not all are safe or vetted. Verify before installing into any production workspace. Browse mcpservers.org. Find the ClickUp MCP. Every MCP has a JSON snippet on its page. Copy it, paste it into Claude Code and type, install this in my local workspace. Claude finds the config file and installs it. Now open a new Claude Code instance. Required step, the MCP won't load in the current session. Type /context in the new instance. Look at that. Check the token cost. Now compare that to what your skills cost. You already saw the numbers. That's the trade-off. MCPs are fast to install. They're expensive to run. Here's the move that saves you money long-term. Install the MCP, test the task, confirm it works. Then tell Claude, take what you just did, convert it to a skill, use the API endpoints directly, and check my other skills for formatting reference. The new skill has a tiny token footprint compared to the MCP, same outcome, fraction of the cost. In real tests, tasks that took minutes and thousands of tokens via MCP finished in seconds with a skill. One exception worth keeping permanently, the Chrome DevTools MCP. It lets Claude control and inspect a live Chrome browser, significantly higher quality and faster than built-in browser tools. Verify the install location before recording. Use cases, browse sites, take screenshots, click elements, fill forms, extract page text, scrape without an API. Section 9, sub-agents. Sub-agents are not a cure-all. Get that straight first. The hype around agents is massive right now. Everyone's talking about multi-agent systems, autonomous AI fleets, agents managing agents. It sounds incredible, and some of it is real, but most people who jump into sub-agents too early end up spending more money, getting worse results, and debugging coordination problems that didn't need to exist. Sub-agents are powerful when used correctly. They're expensive disasters when used carelessly. This section teaches you the difference. Most things you can do with sub-agents, you can do with a single parent agent. Their actual value is speed through parallelization and cost savings through cheaper models. Let me be specific about what parallelization actually means here. Without sub-agents, Claude does everything sequentially. Write code, then review it, then test it, then fix issues, then test again, one thing at a time. With sub-agents, the parent writes code and immediately spawns a reviewer and a tester running at the same time. Two tasks happening simultaneously instead of back-to-back. For a single small task, that parallelization doesn't matter much. For a large project with dozens of files and hundreds of tests, it cuts your build time dramatically. The cost savings angle is equally important. Opus is expensive. It's the most capable model, but you're paying premium for that capability. Most sub-agent tasks don't need premium capability. A code reviewer doesn't need Opus level intelligence to spot a missing error handler. A test generator doesn't need Opus to write unit tests. Sonnet handles these tasks perfectly at a fraction of the cost. So instead of one expensive Opus agent doing everything, you have one Opus agent making the hard decisions and 3 cheap Sonnet agents doing the execution work. Same output, lower bill. Here's how they work. Each sub-agent lives in the .claude/agents/folder. Each one has its own self-contained ephemeral context window. Results always return to the parent agent that called them. Context is temporary. If a sub-agent fails, recovery requires a rerun. That temporary part is critical. A sub-agent's context window is born when the parent spawns it and dies when the task is complete. It doesn't carry memory from previous runs. It doesn't know what happened in the last session. It doesn't know what other sub-agents are doing. It receives a task, does the task, returns the result, and disappears. That's it. This is by design. Ephemeral context means sub-agents are cheap. They don't carry baggage. But it also means they're isolated. If a sub-agent needs information from another sub-agent, the parent has to pass it explicitly. They can't talk to each other. The parent is the only bridge. And the failure model is important to understand. If a sub-agent crashes halfway through a task, there's no resume. There's no pickup where you left off. The sub-agent's context is gone. You rerun the entire task from scratch. That's why keeping tasks small matters so much. A sub-agent that's supposed to review 5 files and crashes on file 3, you rerun the entire 5-file review. A sub-agent that reviews 1 file, if it crashes, you rerun 1 file. Small tasks mean small failure costs. Now, the most important concept in this section, the reliability math. 10 agents with a 95% individual success rate means a coin flip that all 10 finish correctly. That's not a theoretical edge case. That's what happens in practice. Let that sink in. 95% sounds great for a single agent. You'd take those odds any day. But probability compounds multiplicatively when you need all agents to succeed. It's not 95% times 10, it's 0.95 to the power of 10. That's 59.9%. Roughly a coin flip. And at 50 agents, 7.7%. You're almost guaranteed at least one failure. This isn't a theoretical math exercise. This is what happens when people spin up ambitious multi-agent workflows without thinking about reliability. Here's what that looks like in practice. You spawn 10 sub-agents to process 10 different sections of your codebase. 9 finish perfectly. 1 fails silently. It returns a result, but the result is wrong. Maybe it misread a file. Maybe it made a bad judgment call. Now you have 9 good results and 1 bad result mixed together. The parent agent doesn't know which one is bad. It synthesizes all 10 results into the final output, and that one bad result corrupts the whole thing. You don't notice until you're testing the final product and something doesn't work. Now you're debugging across 10 agent outputs, trying to find the one that went wrong. That scenario is real. I'm not exaggerating. It happens constantly when people scale agents without thinking about reliability. The implication is simple. Keep every sub-agent's task as simple and focused as possible. Never compound tasks. Every added complexity multiplies failure risk across the fleet. What does simple and focused actually look like? Here's the rule. A sub-agent should do exactly one thing, not review the code and run the tests. That's 2 things. Review the code is one agent. Run the tests is another agent. If one fails, the other still succeeded. You isolate failures. You can rerun just the part that broke. The moment you combine 2 tasks into one agent, you've doubled the failure surface and made debugging twice as hard. Another way to think about it, if you can't describe the sub-agent's task in one sentence, it's too complex. Review this file for error handling issues. One sentence, good. Review this file for error handling issues, then check the test coverage, then suggest improvements based on best practices, then generate a report. That's 4 tasks pretending to be one. Split them. Each one becomes its own agent. Yes, it's more agents, but each one is simple, reliable, and independently restartable. Type, create 3 sub-agents and save them to .claude/agents/:a code reviewer that receives finished code, reviews it with fresh eyes, and returns specific issues. A QA agent that generates tests, runs them, and fixes failures. A research agent that runs parallel web searches and returns a compressed summary. Claude builds the 3 agent definition files. Watch them appear in the agents folder. Then open a new Claude Code instance to load them. Required step, same rule as MCPs. Notice the design of these 3 agents. Each one does exactly one thing. The code reviewer reviews. It doesn't fix. It returns issues. The parent decides what to fix. The QA agent tests. It generates tests, runs them, and handles failures within the testing domain. It doesn't touch the source code directly. The research agent searches and summarizes. It doesn't make decisions based on what it finds. It returns compressed information for the parent to act on. Every agent has a single responsibility and a clear handoff point. That's the pattern. When you design your own agents, follow it. Add this workflow to your Claude.MD. Write, parent agent writes code. Code review, spawn the code reviewer, fix blocking issues. QA, spawn the QA agent, generate and run tests, fix failures, ship. Adding this workflow to your Claude.MD is important because it makes the pattern permanent. Without it, the parent agent has to figure out when to spawn sub-agents every time. With it, the workflow is automatic. Parent writes code, spawns the reviewer, fixes issues, spawns QA, handles test failures, ships. Same sequence every time, consistent, reliable. And because it's in Claude.MD, every session starts with this workflow already loaded. You don't have to explain it again. A few best practices before you start spinning up agents. Use Sonnet or Haiku for sub-agents. Reserve Opus for the parent. Keep spawn tasks simple and single focused, never compound. Don't return large outputs to the parent. Have sub-agents apply results directly. Always open a new Claude Code instance after generating agents. Use sub-agents with skills for pre-existing workflows, not for simple one-off queries. And one thing people learn the hard way. Spinning up a sub-agent for a simple task can take just as long as having the parent do it. Save them for work that actually benefits from parallelization. Spawning a sub-agent has overhead. Claude needs to create the agent, load its context, send it the task, wait for the result, and process the return. For a complex task that takes 5 minutes of actual work, that overhead is negligible. For a simple task that takes 10 seconds, the overhead might be longer than the task itself. You spent more time setting up the agent than the agent spent working. That's negative value. The break-even point is roughly this. If the task takes less than 30 seconds for the parent to do directly, don't spawn a sub-agent. Just let the parent handle it. Sub-agents earn their cost on tasks that are either time-intensive, parallelizable, or both. The don't return large outputs to the parent point deserves more explanation too. When a sub-agent finishes, it sends results back to the parent agent. Those results land in the parent's context window. If a sub-agent returns a 2,000 line code review, that's thousands of tokens suddenly dumped into the parent's context. Multiply that by 5 sub-agents and the parent's context is flooded with sub-agent output. The fix is simple. Instead of returning large results, have the sub-agent apply changes directly. The code reviewer writes its findings to a file. The QA agent fixes the test failures itself. The parent just gets a short status message. Review complete. 3 issues found and documented in review.md. Tiny context footprint, same outcome. 1 level up, agent teams, they exist. They're experimental, disabled by default, and roughly 7 times the token cost of a single thread. Instead of reporting to a parent, team members are fully independent Claude instances that can message each other and self-coordinate through a shared task list. This is a fundamentally different model from sub-agents. With sub-agents, there's a clear hierarchy. Parent at the top, sub-agents below, results flow upward. With agent teams, there's no hierarchy. Every agent is equal. They share a task list. They pick up tasks, complete them, and post results that other agents can see. They coordinate among themselves without a parent telling them what to do. It's closer to how a real team works. And like a real team, it can be incredibly productive or incredibly chaotic depending on how you set it up. The use cases are real. Design exploration, spawn 3 agents, and each builds a different website variant. Adversarial analysis, debate agents argue whether a security finding is real. Large-scale code-based audits, the cost is also real. Careless agent team use can run $10,000 plus per day. That $10,000 number isn't hypothetical. Each agent in a team is a full Claude instance running independently. Every message between agents costs tokens. Every task pickup costs tokens. Every coordination step costs tokens. And because there's no parent controlling the flow, agents can get into loops. One agent posts a result, another agent questions it, the first agent defends it, the second agent re-examines, back and forth, burning tokens on a debate that might not even matter. Without guardrails, agent teams will happily spend your entire budget arguing with each other. That's why they're experimental. That's why they're disabled by default. So when do agent teams actually make sense? When the task genuinely requires independent perspectives that can't be achieved sequentially. Design exploration is the perfect example. You want 3 completely different website designs. If you use sub-agents, the parent's taste influences all 3 because it's directing them. With a team, each agent works independently, brings its own perspective, and the results are genuinely different. That diversity of output is what you're paying for. If you don't need diverse perspectives, if you just need the same task done 3 times in parallel, use sub-agents. They're cheaper and more predictable. Enable them with this in .claude/settings.json. Set Claude_code_experimental_agent_teams to 1 in your env configuration. Start small, watch the token counter. And if you're running multiple agents on the same code base, look into Git worktrees. They give each agent an isolated folder so they can't override each other's work. Git worktrees solve a real problem. When 2 agents edit the same file at the same time, one overwrites the other. That's not a bug, it's a fundamental conflict. Git worktrees create separate copies of your code base, one for each agent. Agent A works in its copy. Agent B works in its copy. When they're done, you merge the results. No conflicts during execution. Conflicts only happen at merge time, where you can handle them deliberately. If you're running agent teams, work trees are practically required. Without them, agents will corrupt each other's work and you'll spend more time fixing conflicts than you saved through parallelization. Here's my honest recommendation on agent teams. Don't use them yet unless you've already mastered sub-agents. Sub-agents teach you how agents work, how they fail, how to keep tasks simple, and how to manage token costs. Agent teams amplify all of those lessons by 7 times. If you haven't learned to manage 3 sub-agents efficiently, 5 team agents will eat your budget alive. Master sub-agents first. When you're comfortable, when managing agents feels routine, then experiment with teams on a small task with the token counter open. That's the responsible way in. Close what you can build now. Here's where you are after both tracks. You can build and deploy websites using the screenshot loop in minutes. You can build full-stack web apps with authentication, database, and payments using Plan Mode, Supabase, and Stripe. You can create reusable skills for any recurring task. Install and prototype with MCPs, then convert to skills for production. Run sub-agents for parallelizing bulk work with automatic testing and code review. Manage token costs proactively using /context, /compact, /clear, and smart architectural choices, and build automated systems combining scraping, site generation, email, and direct API skills. That's the system. AI is your hands. You supply the direction. Plan before you build. Verify after you build. Every Friday, I run a free live training. The 5 numbers that explain why you have 0 clients. I show you which number is broken and what to fix this week. Show up live, you get the diagnostic template. No replay. iChrysly.com/training. Link in the description. I'll see you in the next video.